Well, so I'm going to try to explain standards 8.6 or at least 8.8. All right, so the first one is opposite of oxidation, and that is reduction, right? But you should know that in oxidation and reduction, the charges are conserved first. Okay, so whatever is reduced, the amount of electrons used to be reduced will be equal to the amount of electrons used to oxidize. Right? So if you gain 2 electrons, you'll also lose 2 electrons. Right? So in a redox reaction, the number of electrons lost is equal to the number of electrons gained. Right? So they involve transfer. Some will be lost, some will be gained, but whatever it is, they will equal each other. Same thing here. So conservation of charge. Right? So here, copper lost 2 electrons, but silver gained only 1 from positive 1 to 0. So it can't be that, right? Over here, magnesium, this is 4 electrons total because there's 2 of them. So this can't be right because this is losing 4 electrons. And then zinc, let me clear this up. So magnesium is losing 4. And then zinc is only gaining 2. So it can't be that. That's not conservation. Right, and this one here, I have 2 fluorine atoms, or 2 diatomic fluorine atoms with 2 negative fluorines. So this is gaining 2 electrons. And then, yeah, this is just all wrong. Right, then I have bromine here, going from -1 to 0. So this is losing 1, and that math does not add up. It has to equal each other. Let's try number 4. So 2 iodines, so that's -2, because there's 2 of them, and it becomes I2. Right, so I2, 0. So that means this had to gain 2 electrons to become -2, or 2I, -2. Right, let me erase this so it's more clear here. That one should work. There we go. So this will be -1 times 2, which equals -2 total. So -2 on the left side, and then I have -2 on the right side from these 2 electrons. Right? And over here, for chlorine, I have Cl2, which are 0, becoming 2Cli -1, which is a -2 charge. So that means this gained 2 electrons here, right? From 0 plus -2 equals -2. Then over here, I lost my electrons. I went from -2 to 0, right? So that means my oxidation number is going up, which means I lost electrons, right? It's on the product side. These are difficult to process. So I'll rewatch this if that did not make sense. But again, these 2 iodines, right, went from negative to positive. I'm sorry, negative to 0. So that means they lost electrons. And this was from 0 to negative, which means they gained. They gained and lost the same amount. Okay. The next one, hopefully this will help as well. So if you lose 1 mole of electrons, well, you must gain 1 mole of electrons. And again, mole, what does that mean? That means amount. So 1 amount of electrons, 1 amount of electrons. And if you don't want to memorize that, it's on table D on the reference table. Okay, so again, number 15 is the same thing. Number of electrons gained is equal to the number of electrons lost. So straight from the standard, should be a basic skills question. And then again, a lot to read here. Let's read the question first before we read all this. Or look at that. Compare the number of moles of electrons lost and number of electrons gained. So this was all garbage, irrelevant, and it's the same thing as a standard. The number of electrons lost will equal the number of electrons gained. Right? The number of electrons oxidized will equal the number of electrons reduced. Right? Same thing here. So a lot to read. This is why people fail if they spend too much time reading irrelevant information. Read the question first. If you need to read the text, read the text. State the number of moles or the amount of electrons that are gained when 5 moles are lost. So again, 5 moles are lost, 5 moles must be gained. Okay, so save yourself a lot of mental energy by reading the question first. All right, moving on to standard 8.7. This is a hard one. So oxidation numbers can be assigned to atoms and ions. Changes in oxidation numbers indicate that oxidation and reduction have occurred. And you must remember that atoms are neutral and have no charge. So when you see an element by itself, it has no charge. Right, so let's first identify what's by itself. Nickel will have a 0 charge by itself. H2 is one element or atom by itself, so that has 0 charge. Okay. What's happening to nickel? Well, if it's becoming nickel atom to nickel ion, I have to figure out what's the charge of nickel in Cl2. Well, if Cl, if I look on the reference table, I know chlorine is -1, right? I have 2 chlorines here, it's Cl2. So I have chlorine twice. How do I balance out 2 -1 charges, which equals -2? I need a +2, right? So nickel and nickel chloride will be +2. So is that oxidation or reduction? Well, if the number goes up, it's oxidized, which means electrons are a product, which means it's oxidized, right? So to go from 0 to +2, we lose 2 negative numbers, right? This is one of the hardest things I've learned for students to process in the last 15 years. They don't understand that when you lose a negative number, you become a higher charge. So if you lose -2, you're +2. That is really hard. I even tried to explain to some college students for like 10 minutes, and they don't understand how losing a negative number is positive. If that's difficult for you, please see me after class one day so I can explain it further. Moving on. Oxidation number of copper. All right, so copper here is in a compound. So what's the charge of copper and copper chloride? Well, it's the same thing as we did before. Chlorine, when it's in an element, or it's in a compound, is -1. There are 2 of them. So that means the total would be -2. How do I balance out a -2? +2. Right, so the charge of copper is +2. So it can't be 1, can't be 4. And then it goes from copper in an ion to copper by itself. So that would be +2 to 0. Right. Please let me know if you need more help identifying the charges when it's in a compound. But you have to do math. Okay? Yeah. So atom, you don't have to read this. An atom always has a neutral or 0 charge. You have to know that. It's an easy question on the Regents if you get it. Okay. State the oxidation number of oxygen in the aqueous product. Well, if you look on the chemistry reference table, you'll notice that oxygen will always have a -2 charge. So if we didn't know how to do the math here, didn't know how to do this, we'd have to look on the reference table. But they're talking about NaOH. Na, if you look on your reference table, was always +1. Oxygen is always -2. And hydrogen, the first charge is positive, right? Let's do the math here to make sure we're not crazy. Does 1 plus -2 plus 1 equals 0? Yes, it does. So that is why the charge of oxygen is -2, and that's why it's +1 for sodium and +1 for hydrogen. These are very hard to conceptualize. So please watch this again or just ask for help or just keep watching. Right. So what's the change in oxidation of zinc? Right. So zinc is 0 here because it's an atom. There's nothing with it. It's just one capital letter. And here, right, if I know oxygen's always -2, what balances out or cancels out -2? +2. So it goes from 0 to +2, which is oxidation. So it loses 2 electrons to oxygen. Okay, next one. So a lot to read, right? Let's read the question first. Determine the change in oxidation number of carbon in equation 1. Right, equation 1 is here. So what's the charge of carbon in CH4? Okay, so CH4 is like this. And you should know, I guess there's an exception here. Hydrogen will always be +1. So hydrogen's +1 here. So I have 4 +1, +1, +1, +1, and then you have what balances out +4? Well, you need a -4. This is one of the few exceptions when the positive ion does not go first. Which very rarely happens, and that's why chemistry is difficult. So it's -4, right? So it's -4 for here, and each hydrogen's +1. What about carbon dioxide? Well, we know oxygen is always -2, and there's 2 of them. So it balances out -4, +4, right? So on this side of the equation, it's +4. This side's -4. So that's why it goes from -4 to +4. Right. Next one. Last one I'll do. Okay, so a lot to read here. Let's read the question first before we read any of this hoopla. Determine the change in oxidation number for oxygen in this operating fuel cell. Right. So it looks like we have to at least read the equation. So it goes from O2 atom. So O2 by itself is going to be 0 because it's not bonding with any other element, to H2O, right? Again, oxygen is always -2 for the chemistry regions, right? And then hydrogen here would be +1 if you're curious. So 2 +1s bounces out the -2. And that's why it goes from O neutral to -2. So it was reduced. Gain 2 electrons, become -2. And that's why the answer is 0 to -2. Right? Please rewatch this or message me on Remind. This again is one of the hardest things to recall. So please don't hesitate to email me or send me more questions about where you got lost. All right, thanks for watching.